Hello and welcome back to the Rawkode Academy. I am your host, David Flanagan, although hopefully you know me from across the internet as Rawkode. Today we're taking a look at another open source project. This one is Kamaji. It's going to simplify your Kubernetes control plane life. We're going to dive into that in much more detail in just a moment. But first, I want to introduce our guest who's going to guide us through the Kamaji journey, Dario. Hello, Dario. How are you?
Hey, everything is fine. Hope the same for you. Nice to meet you all.
Thank you very much. Yeah, I'm doing good. I'm always excited to take a look at a new open source tool, especially within the Kubernetes space. I like playing with Kubernetes and I like my Kubernetes to be easier. And I'm pretty sure you're going to show me some really cool things today to make my life happier and better. And if I get more sleep, I'm a happy man. And we've already had a comment in the chat from Engine who's very curious about the claim with a fraction of the operational burden. So yes, we are going to make your Kubernetes lives easier today. But before we do that, can you please tell us a little bit about yourself, please?
Sure, absolutely. So my name is Dario. The surname is Tranquitella, but I know that it's really hard, especially because from abroad, it's really hard to pronounce in the correct pronunciation in Italian. And I'm based in the north of Italy, near Turin, and I'm software engineer. I fell in love with containers since a sizable amount of years. Honestly, I don't remember. And I was a developer, a web developer, and I faced the issue to scale my applications across the cloud and to the infinity and beyond. And I fell in love with Docker and then OpenShift. I use also Mesosphere DCOS, and it was really a tough job. And then I started working on Kubernetes. I started working in a cloud provider, and I was responsible for the site reliability engineering stuff. And I started developing operators, controller times, and I had the time to starting the code base and especially trying to combine my software skills, my software development skills with the systems. And starting from 2020, I joined Classics as a technical advisor, and I'm doing the technical stuff. So I write software, I do demos, and so on and so forth. And it's really fun. I'm enjoying this job.
Awesome. So this is the first Kubernetes open source project from Classics, right? You also help maintain Capsule, I believe.
Yeah. It's the second one. We started with Capsule because we noticed that there is a missing gap in Kubernetes ecosystem, especially regarding multi-tenancy. So instead of spawning several Kubernetes clusters, you can use just a single one, and you can isolate the namespaces into a tenant abstraction. So the tenant abstraction is pretty common because when you got multiple namespaces, you're ending up grouping them into this abstraction. It's a layer that is a collection of namespaces. But sometimes you have to spin up multiple clusters for various reasons. Maybe because you would like to avoid at all the noisy neighbor effects, or you would like to use different API versions, different Kubernetes clusters, so on and so forth. So we started thinking how to address the real hard multi-tenancy, because Capsule is addressing the soft one, so just namespaces. But I would like to bring my real own nodes and having a real control plane that I can use, so I can toggle dynamic admission controllers, I can fine-tune parameters, and so on and so forth. And this drove us in drafting Kamaji that I'm going to present today.
Yeah, you seem to be quite fond of solving the hard problems with Kubernetes, like multi-tenancy and control plane commoditization.
Yeah,
I guess as if
absolutely.
you just woken up about how can I make my life a little harder today, but at the same time help everyone else. So I really appreciate that you are working on these hard problems because multi-tenancy is hard, and yeah, so it's good that there's much more sophisticated and better tooling coming out to kind of help people with that. So
Yeah,
with
totally agree.
So with that being said, why don't you kind of touched on it there about what Kamaji is, but do you want to give us the slightly longer description? What is Kamaji for, and what problem does it solve for people?
Well, I started using Kubernetes starting from 2016, and at the time I don't remember, but I'm pretty sure that there was a huge bash script that was used to install a Kubernetes cluster. It was create cluster or something like that, And it was a pain to manage that. I remember that all the people that I was meeting in Italy, they were using Kubernetes, but using the managed services by GKE, so by Google Cloud Platform or by Azure. So it was really hard to set up a Kubernetes cluster, but the community addresses that problem and started developing nice projects. And the most satisfying one is obviously kubeadm, because with kubeadm we can configure the worker nodes, the control plane. So we got all the building blocks to create a full-fledged installation of a Kubernetes cluster. And after that, we ended up also with Cluster API, and it's really great because in the end, it's not a wrapper. Sorry if I'm saying something that is not entirely correct, but it's wrapping around kubeadm, although you can specify different bootstrap options. But with Cluster API, you're ending up spawning multiple clusters. And with that said, I noticed that a lot of people, instead of trying to solve the multi-tenancy issue in the Kubernetes ecosystem, they started spawning multiple clusters. And the first one, the second one, the third one, and you're ending up with dozen or thousand or hundred of clusters according to your dimension of your company and so on and so forth. And I've been there because I was working for this cloud provider, and I remember that the size was a bit impressive to me at that time because I was managing 5 production clusters on bare metal, and the overall amount of virtual machines was 2,500 nodes virtual machines, but on bare metal. So you can understand that I was getting page duty during the night, and I didn't enjoy that job honestly so much because it was really cumbersome to manage. We are ending up saying, okay, you can manage Kubernetes scale, you can have multiple cluster, and you can do everything so perfect, but you're ending up obviously with some side effects. So although you're trying to automate everything, you're ending up with some alerts or some tasks to perform according to the timing. So rotate certificates or eventually controlling the node saturation and so on and so forth. And at that time, I was developing a lot of operators, a lot of custom controllers, and I ended up saying, we got operators. Operators are translating the human knowledge, the human operator knowledge into code. And in the end, I'm doing a lot of repetitive tasks, taking care of a Kubernetes cluster. So why cannot create an operator that is taking care of all these activities? I was thinking about this project for a long time. Then I joined Clastics. I was on the same line with Adriano, my business partner. And with that said, we decided to start developing Kamaji. And right now we got this. It's not a proof of concept because it's working. And we got customers that are already using that. We are really happy for that. And yeah, that's the reason why I'm here. I started with multi-tenancy, and now I'm doing deep Kubernetes stuff, the kube inception.
Nice. Yeah, I mean, you said that you've done bare metal Kubernetes, and that's something that I'm really passionate about as well. I like to run my Kubernetes as close to the metal as possible, but I think the pattern that I've seen, I'm sure you've seen it too, and we're seeing loads of other projects kind of follow suit here, is that for the worker pools, yes, you want to be running on the metal, but the control plane, you probably want to virtualize it. Like, those control planes aren't really doing a lot of heavy lifting. They're really just writing to etcd and answering some API requests. And to run them on metal is usually a waste of CPU and memory. And
Yeah.
plus, we need to be able to handle the upgrade path for these control plane nodes in a pretty safe manner. And bare metal is very, very, very slow to reboot. So that brings a whole bunch of other challenges to it. And I think this is why we're seeing this virtualization of the control plane become a more popular pattern. Then with an interesting one I've seen recently was, Weaveworks are pushing Firecracker for the control plane, but then bare metal worker nodes. And I think Kamaji really comes into this space as well. And it's like, yeah, like we can virtualize this and then run all your work, bring your own worker pool, bare metal or not. And I think this pattern will become even more prominent as time kind of progresses.
Yeah, absolutely. Anyway,
Yeah.
I would like also to thank you because while we were talking about Kamaji, I told you about the cube inception, and you use this term, the cubeception, and I try to create a set of slides about this topic, so the cubeception. I hope that you enjoy my memes because I really love crafting memes about Kubernetes.
Yeah, I thought the cubeception was a really good kind of prominent capture wordplay on what we're going to be looking at today. So I really wanted that to be there. And in fact, we have a comment from Russell on the chat as well saying, "So is this Kubernetes inception many Kubernetes clusters inside of one Kubernetes cluster?" Uh, kind of. I think we'll see in just a minute. I'm going to let Dario present some slides, and we'll take it from there.
Yeah,
Engine
absolutely.
does ask a question as well. I don't know if you want to tackle it now or wait till after your slides, but he says, "Is this similar to SAP Gardener in a way to handle the control plane?"
Yeah, it's pretty similar, but we will show you. I don't want to spoil that.
All right. Well, you are sharing your screen, so I'm going to pop over to there. Feel free to
Yeah,
take it away, and if I have any questions, I'll throw them at you as we go.
sure. Great. Thank you so much. So, welcome here, and I would like to present to you Kamaji. And as David said, this is the cubeception because we are doing something really weird, at least according to the majority of people. But I would like to start from the beginning because I've been a developer. I've been on the other side, and I was uh, one of the people asking, I would like to use Kubernetes, but I don't want to manage that. And right now in 2022, a lot of people is using Kubernetes. I say most of the companies around the world are using Kubernetes because is used to create your software as a service solutions. It's used by AI, machine learning, or analytics applications, and also on the edge, thanks to the Internet of Things. And as I said, I've been there. I can say that shameless. Sometimes we feel the burden of the complexity of Kubernetes. So we would like to offload everything to managed providers, or if we can, also to the infrastructure team, if we have an organization like that. So why we need that? Because in the end, we are developers. We would like to focus on the applications, and we don't want to manage a Kubernetes cluster. I don't know. Maybe there is people around the world that are excited to get paged during the night. I wasn't, so I would like to get something that is solving all the problems. So this is the reason why I started developing Kamaji. And what are the challenges? Because with Kamaji, we are aiming to build a sort of building block. It's not a product. I'd say it's just one of the tools to create multiple Kubernetes clusters. And there is a huge lack of tools, especially in the open source. Um, we know that there are some players that are already providing multi-cluster management. For example, there is OCP, OpenShift Container Platform by Red Hat. There is also SUSE that acquired Rancher a few years ago, and we got also VMware Tanzu. And they're absolutely great. Developer experience on top of that is absolutely mesmerizing because I also work with OpenShift Container Platform, and for developers it's great. But there are some downsides, I'd say, because all these tools are designed for enterprises. So it means that you have to stick to their way of doing stuff. And besides that, there is also a high total cost of ownership. You got licenses, you got operations. It's not straightforward. I say it's not real Kubernetes because in the end you're using Rancher, you're using Tanzu, you're using OpenShift, and all these solutions are built on top of Kubernetes. Although pretty sure that the API server is the same, but I hope that you're getting the point. It's not clear Kubernetes. It's a opinionated way of managing Kubernetes. And last but not least, all these solutions are pushing on the way to manage the clusters by spinning up multiple clusters. So you're ending up, or you could end up in the cluster sprawl. And what's the cluster sprawl? It's a nice term that has been inherited by the city sprawl, by the sprawl of neighbors when a city is growing a lot. And this is the first reference to Inception because this is the cluster sprawl because we are ending up with a lot of clusters. a lot of skyscrapers, a lot of houses, and so on and so forth. So it's really hard to maintain. I've been there, as I told you before, just few clusters, but it was really cumbersome. And you can imagine what it could be with huge organizations where you have to manage and keep care of multiple clusters. Anyway, there is another meme, and why we started this project, because I love complex stuff, to be honest, especially when you have to write code for complex stuff. And I remember the first time that I saw Docker in Docker used by GitLab, and it was really interesting because you're ending up with Docker inside that Docker container, and you can do a lot of stuff. Essentially, GitLab pipelines is built on top of that. And then suddenly I discovered the operators that are really great because in the end, you are flooding all the silly task to a software, to a binary. It is running inside the cluster, and it's a binary, it's a software, it doesn't have bugs. Well, just joking. But you can do whatever you want and focusing on or your infrastructure or your code and so on and so forth. And then I saw also, I'd say, together the database on Kubernetes, the rise of databases on Kubernetes. And I remember that a lot of people were saying, no, we cannot use databases on Kubernetes. It's too much complicated. We can't do that. And in the end, we saw a lot of vendors starting developing operators, starting offering database as a service backed by Kubernetes itself. So it means that it could be done. And lastly, I ended up also with Kind, that is Kubernetes in Docker. So it's inception inside inception. So we are ending up with a Docker container that is a Kubernetes cluster that you can use for testing, for CI, for development. For example, I'm using Kind a lot for the development. So it's 2022 and we can do that. But while I was thinking about that, I started asking myself, I cannot really do that because we know that in the end, Kubernetes cluster is pretty complex. I'd say we got a lot of components, a lot of business logic. I mean, it's not like a classic web page where you got the database, you got the front end, you got the back end of the story. But with Kubernetes, obviously, we got a lot of components involved. We got the certificate authority, we got the certificates management, we got the backing storage, and so on and so forth. So I started asking myself, how can I do that? And I started trying to define the pillars of Kamaji, because our idea is saying, okay, we got applications that are running on Kubernetes that got a backing storage. In the end, Kubernetes is made of several components. I'd say the first one is the stateless one, because we got the API server that is connecting to etcd. Then we got the controller manager and the scheduler that are connecting using the kubeconfig for their own component using the API server. So API server is absolutely stateless. All the state is stored in etcd. So the idea was to say, let's try to move the multi-tenancy from the infrastructure level, so from the virtual machines, to the containers, as we are doing with the applications. But multi-tenancy must be moved into the data store. So you know all that etcd is the key value store that we are using for Kubernetes. And starting from version 3.5, has been introduced a new feature that is named the etcd namespaces. And too long didn't rent. It's a sort of schema of the databases. So in MySQL or on PostgreSQL or whatever database you would like to use, you got the schemes, and essentially it's the same stuff. So in the etcd, to be honest, you're ending up just with a prefix of the keys, but you can use certificates, user roles, just to segregate this data, and you're ending up with namespaces like the ones of Kubernetes. And after that, as I told you all before, it's kubeception, because in the end, we are using Kubernetes to manage Kubernetes itself. So our Kamaji is orchestrating the pods that will be the virtual control plane, and is going to manage also the shared data store. But I guess that also a picture is more worth than 1,000 of words. So here it is, the architecture, and I'll try to describe it in the best way possible. So Kamaji needs a Kubernetes cluster, because otherwise that will be an egg chicken problem, because we have to manage multiple clusters, but we need a cluster. So the cluster must be created in advance. And it means that we need an admin cluster, something that could be named a management cluster. And this could be any Kubernetes compliant cluster. It could be whatever version you would like. For our demo, we are going to use a 121 or 122, I don't remember, Kubernetes cluster. And inside this cluster, we are going to install also Kamaji through an Helm chart. And this Helm chart is installing the CRDs. We got the tenant control plane CRD that will spawn these pods that are the virtual control planes. But how these pods are connecting to the etcd? Obviously, we got a multi-tenant etcd that, for the sake of simplicity, has been deployed inside the admin cluster, but it could be also outside of your cluster. It's not a prerequisite. It's up to you to manage etcd. We developed the Helm chart, and the Helm chart is taking care of setting up the etcd, enabling the feature for the multi-tenancy, generating the certificates, and so on and so forth. So with that said, when we are creating a tenant control plane using Kamaji, we are ending up with a pod, and this pod is exposed using a node port, an ingress, exposed using a load balancer service, and obviously those pods are a cluster, but they are missing the nodes, because Kamaji is not using the nodes of the admin cluster, but is exposing all the I would say that the endpoints, all the information required to perform the bootstrap of nodes to join that cluster. So in the end, we are ending up with the definition of the tenant node pools. So it means that these are worker nodes. They could be also containers, they could be Firecracker virtual machines, they could be virtual machines or bare metal instances. They just need to join the cluster using kubeadm. And another meme, because I'm really in love with meme, because you can understand there are so many components that are moving together, because when we are dealing with the API server, we need the certificates, we need the kube config, we need the config map with the kubeadm configuration. There is also spoiler alert down there. We got also connectivity. So Kamaji is trying to simplify the management of all these silly tasks in an automated way. So I'd say that the next step is starting the demo time. And obviously, I have to summon the demo god, because I tried several times the demo. It's working, but it's also Murphy's Law. So fingers crossed.
Yeah, now that we're all looking, it's a whole different ball game. But we do have a question in the chat if you're happy to answer that just before you jump into the demo.
Sure.
So Russell says, is the admin cluster etcd also the etcd used by each tenant cluster, or do we need separate ones?
Yeah, I'd say that, it really depends. But honestly, I would avoid the single point of failure, because in the end, what happens if you break the etcd using Kamaji or something like that? So you can do that. You can use the same etcd, but honestly, I will avoid that, just to be sure to decrease the point of failures. So having etcd for the tenant clusters will be much better. So you're decoupling from the admin cluster one.
Okay.
You're not putting all the eggs in the same how to say that?
Basket.
Basket. Yeah. Sorry.
Yeah.
I was thinking Italian.
So yeah, so I'll just kind of continue with that a little bit. So you can have one etcd cluster, and using etcd namespaces, you can have the admin cluster one namespace and all the tenants on another. But in production, you probably want one etcd for the admin cluster and then one etcd shared amongst your tenants. Is that what you would kind of promote?
Yeah, absolutely. Also keep in mind that I don't want to spoiler, but I wouldn't haven't used etcd in production. But I don't want to spoil that, because it's really interesting. I'll show you later. Okay. Anyway,
All right. Yeah, carry
we
on.
can
Carry on.
Carry on. So keep in mind that we need a Kubernetes cluster. So what I did is to install, well, not installing, but creating a Kubernetes cluster on AKS. So I'm on Azure cluster info, as you can see here. So we create a Kamaji in the zone of AKS. It was West Europe. And this management cluster, this admin cluster, as you can see, is 122.1, will get installed with Kamaji. So how can I install Kamaji? It's pretty straightforward because I have to use Helm, upgrade, install. I don't remember the order of the arguments, but I got my history with me. So I'm installing Kamaji from the chart that I got in my local directory. So Helm Kamaji in the namespace Kamaji system and creating the namespace. That's great. And now in the other pane, I'm going to watch watch all the pods that are going to be created. So using kubeNS, I'm switching the namespace in Kamaji system and performing with my beloved aliases kubectl get pods minus w. So I'm watching the pods. When you're installing Kamaji, by default, you're getting up with a netcd in HA, and we are taking care of generating certificates, enabling all the features, and so on and so forth. So right now we have to wait a few minutes, I'd say, for the free replicas, and we should end up with everything installed. Yeah. So in the end, as you can see here, we got etcd, free replicas, and Kamaji. And we got also our CRD deployed, and it's the tenant control planes Kamaji Classics IO. And also, our operator has been deployed, and I can check the logs using kubectl logs -n Kamaji system. I don't remember. So yeah, I got the history. I love the history. -l app Kubernetes IO component controller manager -c manager follow. Just to be sure that the controller is up and running, is watching all the events, and is starting the workers. That's great. And now what we have is to deploy a manifest of the tenant control plane. So I'm entering in classics, Kamaji, and for this demo, I already have a sample that I'm showing with you. So this is the API definition of the CRD, and the name is tenant control plane, and the name is Rawkode. Keep in mind that all these resources of the tenant control plane, since are spawning pod, secrets, config map, services, and so on and so forth, are names is a namespace scope resource. So we can specify the namespace to default. And we can define also various options. So we can define the options for the control plane and managing the deployment, the service, and also the ingress. Well, with the ingress, it's really hard because Kubernetes has not been designed to get exposed using an ingress. So you are not barely using fully qualified domain names. Just for the sake of simplicity, I'm going to use a load balancer. So AKS, well, Azure is going to deploy a service of load balancer type and giving me an API, a public and routable IP address, not API, IP address. Then I'm defining also the deployments up to 2 replicas. And why 2 replicas? Because in the end, if you think about that, we are just managing the API server, control manager, and the scheduler, because all the state will be managed by etcd. And now here comes the really important stuff, because we can define all the information regarding Kubernetes. So I'm saying I would like to deploy 1, 2, 3, and I can set also a configuration for the kubelet, for the nodes that are going to join my new cluster. I'm going to say that I would like to use the cgroup fs systemd, defining some admission controllers, and I can say also extra parameters, extra args for all the components of the control plane. So if you would like to enable some specific cloud integrations or specific flags, you can do that. So we don't have to create a mapping with all the possible informations, all possible settings of the API server, the scheduler, and so on and so forth. Just the most important ones.
Okay, I'm just going to interject very quickly just because you answered a question there. So Engine did ask in the comments, can we set feature flags? And the answer is yes, using the extra.
Yeah, the
right.
extra arts. Yeah, absolutely,
Awesome.
absolutely. Because otherwise, will be really hard to follow everything. And then we got also the network profile, and network profile is really interesting because we can set the address if we already know the address, or otherwise we can set the port that we are expecting to get connections. In this example, we are going to use the 6443, the default one. So I'm going to get my load balancer with my public IP, and it will be the tenant control plane, which will be reachable using that IP on this port. And then I got also the add-ons. So if you are familiar with kubeadm, obviously we are following the same structure. So with kubeadm init, I don't remember, but pretty sure, just need to read the docs. There is the add-ons, so you can configure the core DNS and kubeproxy. It's optional, kubeproxy, because if you would like to use, I don't know, maybe Cilium, I don't want to use kubeproxy, you can do that. Just for information. Sure.
So can we specify our own CNI here, or are we bound by the admin cluster?
No, it's up to the admin cluster.
Oh, yeah, okay, cool. That's what
not the admin cluster, but I'd say the cluster owner. So who's going to use Rawkode? In this case, I can show also the kubeconfig to you, so you can type from your local machine interacting with the cluster if you want. Would be great. Yeah, I wasn't thinking about that. I'm going to share with you also the kubeconfig, so you're interacting with the cluster. Anyway, yeah. We had a discussion internally at Classics if we would like to provide also installation of the CNI, but we try to stick to the convention of kubeadm and cluster API. So when you're spinning up a cluster using cluster API, the CNI must be installed after the bootstrap provision. Yeah, because I could use different CNI for each cluster. So we don't want to be opinionated, but we can talk about that. Don't worry. We are looking for feedback. So this is our definition. That's great. So what I would like to do now is to apply that. So just to be sure. Oh, it's Friday also for me. Kubernetes default kubectl apply -f config samples Kamaji v1 alpha1 tenant control plane. And I'll open also another tab watching for kubectl get tenant control plane. Yeah, the short name is pretty misleading, TCP, but you know, we do love doing jokes. So TCP is tenant control plane. So now I can create it. Fingers crossed. I'll watch again for the logs. And as you can see here, the logs are polluting us, saying, I don't have an address. We have to wait for the address. In fact, as you can see here now, in the get TCP, in the watch, we are ending up with a control plane endpoint. So this is the routable IP that we are going to use for connecting to the cluster using this port, using this kubeconfig, and the status saying that it's in provisioning state. And in a matter of seconds, I'd say, yeah, just now, after 35 seconds, we got a cluster that is ready. In fact, if I try to issue curl -k this control plane endpoint, we are getting our cluster.
Nice.
But obviously, I cannot use curl. If I would like to interact with the Kubernetes cluster, I would like to use a kubeconfig. That's fair. In fact, Kamaji is also generating the admin kubeconfig that is stored in a secret named Rawkode admin kubeconfig. Rawkode is the name of my tenant control plane. So what I have to do is to search on my history and kubectl get secret Rawkode admin kubeconfig output JSON JQ-R data admin config base 64 decoding and piping to TMP Rawkode. we should write a bash code or a plugin to do that, because it's pretty cumbersome. I always use the history. Okay, we got our kubeconfig. I'll show you just for the sake of sharing. And as you can see here, we got our certificate authority data, we got our server, our context, and obviously also the certificate to interact with the cluster. So with that said, I just need to override the kubeconfig to tmp rawkode kubectl version. And as you can see here, we got our cluster because it's 123 and it's the same version that we saw in the tenant control plane definition. So 123 and 123. If I try to issue again kubectl get nodes, obviously we don't have any node. Why this? Because we just provisioned the control plane, and we would like to use Kamaji just for the control plane pods, the virtualized control plane, because the nodes will be in another region. And for this demo, I'd say that the nodes are not on AKS, well, are not on Azure, but rather they are on AWS. So with that said, I already prepared also on AWS launch template. This launch template is using Cloud Init to install all the required components. Let me check because I'm not so much familiar with AWS, especially using the UI. Yeah, as you can see here, we got the cloud config, the Cloud Init configuration. So we are installing containerd, card, performing all the information, well, all the obvious tasks that we have to do to set up Kubernetes cluster. So installing the kubelet, kubeadm, containerd, and so on and so forth. Okay, and we should have also the configuration for containerd. I'm a bit worried because I see that is missing a parameter, but yeah, because I have to use the latest version. Yeah, we have to use the systemdc group driver because otherwise we will end up with some issues. Anyway, from this launch template, I would like to create some set of nodes, and these nodes that are on AWS will join the virtual control plane deployed by Kamaji that is deployed on Azure. So Rawkode worker nodes, I'm going to use the template description. No, I don't want that. Auto-scaling guidance, no. Template tags, source template. I would like to use this one with the latest version. I don't need to use the, my bad, sorry. I don't have to create a launch template, but I have to start an auto-scaling group from this template. My bad. So, Rawkode, Kamaji, Rawkode worker nodes using my launch template, the latest version. That's great. We are going to spin up T3 medium machines. I'm saying in my VPC, all of these, T3 medium, it's okay. Let's go for next. No load balancer, no monitoring, not at all. We just need some machines. So the desired capacity, let's start with 1, maximum capacity 10. And now I'm going to create everything. Okay, VPC settings, create auto-scaling groups. And in the meanwhile, I'm going to share with you, David, the file of the kubeconfig. And I think that I can use the commands. I'll share with you via email, if you don't mind. Okay?
Yeah, sure. Go for it.
In the meanwhile, we can wait for the node to get provision.
Yep. Can I ask a couple of questions as well?
Absolutely, absolutely. Yeah.
So you haven't specified the kube config for the worker nodes. Are we going to be doing that interactively?
No. There are some default values. We are using just the default values for the sake of simplicity.
Okay. And see the control plane containers. Like, I mean, that was pretty fast, like 30 seconds, and we had a control plane. Are those images that you're building and publishing? Are those being like, how do you?
The images were already cached, so it really depends also, because I already tested that before the video stream. But yeah, you have to think also about the pooling of the container images, but
But
it's
what
pretty facilitated.
images are those? What image are you using for the control
Absolutely,
plane?
I can show you that. So let's edit the Rawkode deployment, so we can also take a look to the internals of Kamaji. So obviously we got the owner reference control, we got the owner reference to the time control plane resource that is used for the operator pattern. And then we got our containers. And in the containers, we are defining all the arguments for the API server. So we're defining the etcd servers. And as you can see here, we can define also the etcd prefix. So this is the namespace that we are going to use in the multi-tenant etcd. And then we got the etcd key file and blah, blah, all the informations. Then we got also the following one that is going to be scheduler. And as you can see here, we are using the K8s DCR.io images.
Yeah, these are just the standard upstream
This other
Kubernetes
one,
control plane images. Perfect. All right, cool.
Absolutely. And also for the controller manager. Obviously, we are wanting all the certificates, the CA, and so on and so forth, because all the communication, although is living inside, all the components are inside the same pod. We were thinking about ending up with multiple deployments. So as you can see here, we got a deployment, 2 replicas, and 3 containers. And the reason for that is that in the end, we would like to use the loopback interface for faster connection between the controller manager and the scheduler. So in the end, we don't need a leader election. We don't need to scale differently the controller manager or the scheduler, or we could potentially have that need, but we are open for discussion for that. Keep in mind that it's an open source project, so the governance must be managed by the community. So we are really hoping to get your point, your feedback about that. From the beginning, it was much easier using a single container, a single pod with multiple containers. So let's see also what the community think about that. Anyway, we should have now, fingers crossed, our instances. Yeah, we got our instance. Now I'm connecting to it, just to be sure that everything has been configured properly. So, SSH Ubuntu, that machine, and let me check if Cloud Init has been completed or not. I'd say so, because we got kubelet, kubeadm, kubectl, and just to be sure, I like to play safe. Containerd, config taml. It's not my laptop, okay. Systemd cgroup true. That's perfect. Okay. So now that we got our node, what we have to do? Well, obviously, we have to extract the token for kubeadm to let the node join the cluster. So with that said, I export the kubectl to Rawkode. We don't have any node, and what I have to issue is kubeadm token create print join command. So in the end, it means that we are going to use the exposed IP address on the port with this token, with this discovery token CA cert hash that is used for the CA. So with that said, in the pane that is SSH'd to the node, I'm passing the command and adding v3, just because the God has been really good to me. Everything is working, but I just want to be sure. And in the meanwhile, I'm going to look at to nodes and pods. Obviously, Keep in mind that we don't have any node. And obviously we got Crds kubeproxy that has not been deployed. It's not a big problem. So now in the node, in the AWS node, I'll issue kubeadm join, and the node will join the virtual control plane that is deployed on AKS. We just need to wait for the TLS bootstrap, but here it is. As you can see here, we got our node 10.0.28.98, 10.0.28.98, and we got our kubeproxy, our core DNS, and so on and so forth. But obviously, there is something that is not working because the node is not ready. So what we have to do is to export again our Rawkode and apply the manifest of Calico. That's CNI. You can install whatever you want. It was working for me with Calico, so I don't want to test with another one because everything is so perfect right now, so I don't want to waste everything. So installing Calico, it has been installed, and as you can see here, we are ending up with the Calico node that will install all the CNI binaries and configurations, and our node should be marked as ready in a matter of seconds, or at least I hope so. Yeah, the node has been marked as ready. So we are ending up with core DNS, we are ending up with Calico kube controllers, and all the containers that we are going to deploy inside of our cluster. So just to recap, we got Kamaji installed in a Kubernetes cluster hosted on Azure. This control plane is exposed using a load balancer. The pods are on Azure, and the nodes are joining using the nodes are joining from AWS. So you can use whatever you want. You can do that on bare metal. You can do on your even on your virtual machine using KVM virtual machines or Firecracker VMs, whatever you want. And that's great because in the end, it's I'd say obviously I'm saying that shameless because this is a project I contribute to. But getting the point, you can use Kamaji to create as a building block for a truly managed Kubernetes service. You can imagine maybe a portal, an application where you're telling your developers, click here to create your Kubernetes cluster. Give me your credentials for the AWS account, so you're accountable for the cost of the control of the worker nodes. I'll send you the kube config and so on and so forth. I will install everything on your behalf. So in the end, it's a sort of framework to build whatever you want. But now there is something that is not working, and it's the following one. So everything is working. So I'm really happy for that. We don't have pods that are in restart mode, but let's imagine I would like to take a look to the kubeproxy logs. Obviously, I can do that from the machine. Crydctl ps. Crydctl, where is kubeproxy? It's the latest, it's the last one. Crydctl logs -f. So everything is fine, but I don't have access to that machine because that machine has been installed by the developer. I have the credentials, obviously, but I will try to extract them, connect to the AWS and blah, blah. It's a pain. Also, maybe I couldn't have also the SSH key to connect to the node. So as an administrator of the cluster, I could say kubectl -n kubesystem logs -f kubeproxy. It's not working. Why? Because the node is IP 10.0.28.98 and it's trying to connect to the kubelet port. And here comes the troubles, because obviously, if you think about that, Kamaji is on AKS, is on the Azure network, and the worker nodes are on AWS. Obviously, I can say all the worker nodes must have a routable public IP. I'm letting join the nodes using their public IP, But that will be really cumbersome, also because it means that from the security perspective and also from the security assessment, you can imagine, for big organization, it will be terrible, I say. You have to open the ports, all the firewall, the WAF, and so on and so forth. So it's not manageable. Okay, we noticed that. So there is a nice feature that I would like to show you. And let me unset the kubeconfig, and I'm going to change the definition of the tenant control plane. As you remember, we got the add-ons, and with add-ons we can configure CoreDNS and kubeproxy. But there is also another component, I'd say an add-on, that unfortunately is not managed by kubeadm, and I'm saying that because trying to wire everything in Kamaji has been a pain due to that, and it's connectivity. Connectivity, I'll try to say that using the terms from the documentation. It's reverse proxy for the control plane communications to the worker nodes and vice versa, or vice versa. But I prefer to say that it's a reverse exploit tunnel because in the end, what's going to happen is that we are ending up with two components: the connectivity server that is on the control plane, so on Kamaji, and the connectivity agent. So the connectivity agent is launched as a pod inside the worker nodes. The worker nodes, obviously, they can connect to the Kamaji tenant control plane. They establish a connection, and using this connection, they are starting a bidirectional communication from the kubelet to the API server and vice versa. So with that said, I also to set the connectivity port, or rather the proxy port. And I'm going to say 8142. That's great. Now, what I would like to do is to create another tab, and I will show you with watch -n kubectl get pods secrets service. Could be this one. Yeah. What's going to happen? So I can enter the path where I got my manifest, Kamaji, apply -f config, samples, and control plane. And here comes the pain. Because as you can see here now, we got a new certificate. That's the connectivity certificate. And we are spinning up a new deployment. It means a new pod. Why that? Because we need to get the proxy agent, well, the proxy server sitting beside to the API server, because the API server is aware that there is the connectivity server that will be the tunnel to communicate with the worker nodes. So let's wait now for the reconciliation. But as you can see also from the logs, we got Rawkode, so our instance of the tenant control plane, has been reconciled. So if we take a look here, we got our service Rawkode, our load balancer on Azure with this IP, and now we got also 8142, so the connectivity port. So far, so good. So now we can switch again on our tenant control plane, well, on our tenant cluster. And as you can see here, now we got a new pod. Well, it's not a pod, it's a daemon set. And it's connectivity agent that has been spin up 80 seconds ago. And since I know that things can go wrong, I just want to be sure that the connectivity of the load balancer is good enough. So let me check from the logs, try-ctl logs -f, this one. Yeah, start serving. So with that said, remember that the AWS node has been announced using a non-routable IP. So the API server cannot connect to the internal cluster network because they don't have the same CNI. So it means that webhooks, validating webhooks, mutating webhooks, or whatever it is, it shouldn't work. Now what I have to do is to export again the kubeconfig for the tenant cluster, and I can issue kubectl -n kube system logs -f kube proxy, and here comes the magic.
Nice.
So it means that our connection is getting processed by the tenant control plane API server, is going to be forwarded to the Unix domain socket of connectivity agent that is connected to the node where the pod is running and can interact with the local kubelet. And with that said, it means that we can retrieve logs. We can install, obviously, our CRDs, because in the end, we got a different schema. For example, now, what I can do is to say, upgrade install capsule. It's our shameless self-promotion. Sorry for that, Daniel. But I can install custom CRDs. And these CRDs are interacting with validation webhooks, conversion webhooks. So it means that we are ending up with a lot of stuff, a lot of moving stuff. And in a matter of seconds, we are ending up with capsule that has been installed properly. So you're ending up with multi-cluster management made possible by Kamaji, with the multi-tenancy inside that cluster made possible by capsule. We just need to wait. But it should be okay. Fingers crossed. It was working. I tried that.
Everything has worked so far. It's not going to stop now. I think you're good.
Yeah.
Come on, Capsule.
It's a matter of resources. I remember that. It's a matter of resources. So just to be sure, capsule system, capsule control manager, limits, because I'm not using so powerful machines. That's the reason. Plugin in production. Okay. Yeah, it has been installed. So capsule has been installed. So custom resource definitions inside the etcd, and everything is working.
Very cool.
And with that said, I think that we finished our demo.
Well, how brave are you feeling? Because I've got an idea.
And that's all. So
do you want to jump back to your terminal?
Yeah, absolutely.
Well, our control plane here, can you run kube control get TCP? So the tenant control plane.
No. You in this pane, I can do that.
Yes. Yeah. So that is Kubernetes version 123.0. Can we upgrade that to 124?
Yeah, absolutely. Sure. So let me disconnect from here, and let's go for watch -n kubectl get tenant control plane. I'm going to edit tenant control plane, Rawkode, and let's search for the version. 23.1. And as you can see here, we are entering the upgrading state. And in a matter of waiting for the images getting downloaded and placed in the nodes, we should ending up with the status upgraded and so ready. So it's just a matter of 12 seconds. But obviously keep in mind that we just upgraded the control plane. So you have to manage everything on your own, like cluster API, Terraform, Ansible, or whatever it is, because we just upgraded the control plane. And it's okay. I mean, you upgrade the control plane and then you upgrade the nodes. There is no problem with the version skew between worker nodes and control plane nodes.
Nice. I like that a lot. And Engine said he had that question too. But Engine does have one more question. He was asking if we would be able to add Kilo to the mix, which is a WireGuard-based cross multi-cloud component.
Kilo, I don't know what is Kilo. Never heard about that.
Yeah, I think it would work. I mean, we don't need to dive into that right now, but there's something to experiment with another day. So
yeah, absolutely.
All right. Well, sorry, on you go if you want to.
Yeah, I was missing this slide. My bad, because I fucked up the order. So we got also a roadmap for that, because we know that this project is pretty young. It has been open sourced during the KubeCon in Europe, in Valencia, in 2022. So it's really, really, really young. And we are looking to get some benchmarking and stress tests. So please try to destroy Kamaji. We are looking for that, and we are really happy for that. But obviously, we know that we have still a lot to do, especially with kubeadm. We strongly believe that kubeadm is the right tool to manage Kubernetes cluster installations. So we would like to go in that path. And if you think that's the not correct one, please share that. We got the discussion on GitHub in the Kamaji repository, start discussion. We got also, I forgot to say that, the channel hashtag Kamaji in the Kubernetes Slack channel. So join there so we can talk about that. We will be really happy for that. But obviously, my demo was totally focused on the ClickOps. So I connected to AWS, I clicked here, down, blah, 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 blah. And obviously, it's just for the demo, because having everything automated would be absolutely great, but you will miss all the moving pieces behind that. So we are working with the cluster API integration. We are working also with the Terraform, because a lot of people they don't want to use cluster API because they are managing Terraform for the whole infrastructure, and in the end, the Terraform control plane is going to be considered as a component of the infrastructure, and obviously also with cross-plane. But since I got this heritage from site reliability engineering, I'm working also, and I'm really happy. I will be really happy also having help to achieve that. We are working with the Prometheus metrics, because we need to get monitoring and alerting. Obviously, you can install the metric Sava in the Terraform control plane, but we would like to get also an overview of all the clusters. So getting know how many clusters are performing the upgrade, how many clusters, for example, they got CA that is near the end of the validity, and so on and so forth. Or eventually, how many internal control planes have been restarted for any reason. And last but not least, it's my it's really interesting. This one is the Kine integration. Kine is a nice project. And if you recall, I told you all, if I will use Kamaji production, I will never use etcd. And someone will say, starting raising an eyebrow, how can I use Kubernetes without etcd? I need that. And that's true. But this project that has been formerly developed by Ranger people, and right now is in the process of getting donated to the CNCF. It's in the incubating or staging phase, I don't remember. Anyway, with Kine, you are using an adapter. So it means that there is adapter that is, how to say that, is conform, is using the same signatures of the etcd. So you got this endpoint, and these etcd endpoints are the same signature of a real etcd, and you can use a driver to say all the writes shouldn't be forwarded towards an etcd, but rather against a MySQL, a PostgreSQL, or eventually also SQLite database. Obviously, I will use a database as SQLite for production. It really depends on this, but So with that said, I truly believe that Kubernetes is great, although sometimes I feel the pressure of the complexity behind that. But operators are saving our lives. I mean, with the operators, we are removing the toil of managing complex infrastructure. Kubernetes itself is solving a lot of problems. So if we can use an operator to spawn multiple Kubernetes control planes, and then these control planes, obviously, they need to scale out, because etcd got too many limitations. The first one is regarding its size. You cannot exceed the 8 gigabyte of storage. Otherwise, hic sunt leones. I'm Italian, I use a lot of Latin words. So vice versa, hic sunt leones. It means that here comes the dragons. So you don't know what could happen. And I don't want to deal again with a split brain of etcd or unrecoverable data from etcd. And with that said, we are also working with kind integration. We already have the MySQL one. We are working with the PostgreSQL one, and that's great because with the operators, there is a nice project by EDB, Enterprise DB, that developed the cloud native PG. So it's an operator that you're defining a custom resource, and from that custom resource, you're ending up with the CA, with the certificates. So it's just a matter of connecting all the things together. And with a PostgreSQL managed by Kubernetes itself that can auto-scale, you're ending up of managing a Kubernetes cluster at scale, like an hyperscaler, I'd say. I'm not saying that Kamaji could replace AKS. Obviously, no, neither EKS. But it could be used by your organizations, also by your company, when you are selling or providing Kubernetes as a service to your developers or other teams. And I think that's really great because it's the power of the open source. So you don't need to rely on companies. Obviously, they need to build, they need to pay the salaries for all the software engineers employed by AWS, Azure, and so on and so forth. But you can do that on your home, at home, with a shared governance from the open source community. And I think that's more interesting rather than, okay, I'll buy by AWS or by Azure. End of the story. I cannot say a word about the direction of the project. I don't even know the internals of AKS or EKS. With Kamaji instead, you just need to issue the discussion. With the discussion, we're starting a discussion with the whole team members, with all the community, and we are just committed to deliver a reliable software. End of the story. So these are the links, and I don't know, maybe I told too much. My bad.
No, I love what you're saying, and it's all useful context around what's going on here and how cool this is. I think we have one more question in the chat. What I'll say is, before I pass that question on, if anyone else watching has any questions before we finish up, please drop them into the comment section now. The question that we have is from Engine again. Engine is asking, like, do you plan on supporting other Kubernetes distributions? Could we use Kamaji for K3s or K0s or etc.?
Oh, that's a nice question, honestly. We can think about that. Yeah. I don't think there is any downside about that. Keep in mind that we are just using the default images because in the end, if we would like to use multiple clusters, you're ending up using products by K3s, by Mirantis, or K3s by Rancher, and so on and so forth. So we were trying to commit to the vanilla solution. But yeah, we can think about that. I don't know, maybe we are, but yeah, K3s is CNCF compliant cluster.
Yeah.
So it's a compliance. So I think that also the signature of the CLI flags are the same. So open an issue, open a feature request. Let's try to discuss that, and we can think about that. Absolutely, I will live. I will love that. Yeah, absolutely.
Very cool. All right. I don't think we have any more questions. So with that, I'll say, Dario, thank you so much for taking time out of your day and showing us Kamaji. It's a really interesting project. I think it's something I'm going to have to experiment with on my bare metal clusters and try and get more utilization of those control plane nodes and bring my own worker nodes. So I'll definitely kick the tires on it a bit more and open any issues. But I'm excited. I think this is very, very cool.
Yeah, thank you so much.
Engine is saying, I see Kamaji in the edge IoT context. Feel free to share more on that. Like, is that something you'd considered?
Well, in the end, if you think about that, it's not my field, honestly, because I've been a web developer, now playing with containers. So the edge is really hard. Also the bare metal, to be honest. But I remember that the great problem of the edge is the fact that you're ending up with a control plane on the edge. You need a control plane on the edge because otherwise it's not like Docker's wall. Okay, with Docker's wall, I remember that you were ending up with multiple nodes that were acting as control plane and also as workers, but it was really a bad pattern, I'd say, because you're mixing up the roles. So what happens if an application is killing the control plane components? Instead, with Kamaji, in the end, you just need this sort of connection with the control plane, and you don't need to deploy the control plane on the same edge location. But yeah, it's something that will be absolutely interesting. To be honest, I'm missing the overall picture of the edge because it's a different word than from my usual one. But yeah, I think so. And if I'm wrong, tell me that. No offense at all.
All right. Well, I think we'll leave that there. Thank you again for joining me and for sharing. I hope you have a wonderful day and a wonderful weekend. To everyone watching, thank you for your questions and for joining us today. And we'll be back soon for more Rawkode Live later. All right, Dario, have a good one. I'll see you later on.
Thanks. Ciao, ciao. Bye.
Bye.
Thank you for watching Rawkode